The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kilauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Mauna Loa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? And it was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dan started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed and we knew we were getting to the local community and people were asking questions. So those were the best, I think. I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well and we got to a lot of people we wouldn't have normally got.
Aloha, everyone. I'm geologist Philip Ong, here with Mr. Dane DuPont from the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. Today is Thursday, September 19th, 2024. We have an ongoing Kilauea eruption at Nāpau Crater on Kilauea's Middle East Rift Zone. So we have lots to talk about today, lots of images, videos. We'll try to select some good ones for you guys, go over some of the monitoring, and talk story about this new era of Kilauea. How are you doing today, Dane?
Doing pretty good. Been pretty busy with all the changes that have been happening with the phases that we'll go through of this eruption in detail today, and been running around. We were at the Council for Native Hawaiian Advancement the other day at a conference, and then we were over at Kalapana the other night as well. So running around all sorts of places right now.
Yeah, lots of interest in what's going on, of course, right? Because this is the first activity on the Middle East Rift since 2018. And as we know, that is why we are here, our mission is to help improve preparedness and response through volcano education. And we also remember 2018 and want to improve from the response that occurred then. So people are traumatized. They imagine lava on a Middle East Rift. And so lots to talk through and to make sure we're all on the same page here. And right off the top, there is no increased threat to people living in the Lower East Rift. It's all in a national park and following the typical pattern we've seen before in the 60s, which we covered over the last couple months now. So we'll go through all that. Dana will be leading a discussion on the chat, collecting questions as well. We'll go through in 2 segments today. Since there is so much imagery and videos, we'll do that up front, and then we'll go through the monitoring on the back half. And so Dane will sort questions accordingly there. And anything else you want to add before we get into it, Dane?
No, I think that's it. Again, this is some spectacular footage that we're going to be going through. And you can see just a little teaser there on screen now.
Yeah, this may be the image that most people may have caught familiar recently. This is the highlight of the last 24 hours, at least. So we'll get into what this is and all that here shortly. But maybe let's rearrange our screen first and set ourselves up for our Hawaiian volcano summary. All right. Aloha. This is our Hawaiian volcano summary for September 19th, 2024. Kilauea is erupting on its Middle East Rift at Nāpau Crater, now in its 4th day. And over the past 4 days, the eruption has gone through 4 different phases, which is typical of Middle East Rift activity. While there's a lot of changes, all of this is happening within a national park, and there is no increased threat to people living down in the Lower East Rift Zone. The 4 phases are noted by the USGS here. We had some pre-eruption intrusion of magma. And then what happened is on the very first night of September 15th, there was a very short eruption from 9 to 10 p.m. The second phase was the resumption of activity the following day. The third phase was when we saw fissures opening across the floor of Nāpau Crater and start to fill that crater with lava. And really, that 4th phase began yesterday afternoon with a new crack opening up on the upper rim of the crater and pouring lava into the crater as well. So those are the 4 phases. We can show you what that actually looked like. Here's the very first phase, which is that initial 1-hour eruption with 2 small pads of lava erupted just west of Nāpau Crater. Here's Nāpau Crater. Makapui would be back in this direction, and Pu'o'o would be under this cloud in that direction over there. So we're looking to the southeast or so. So the very first phase was very brief and was still degassing when we saw the second phase emerge and reactivate with lava flows from the upper fissure that poured down, sent the first stream of lava into Nāpau Crater, and then in that next phase opened fissures on the crater floor. Those waned after a few hours. And so you see here an intermediate phase with the lava not flowing very much until it reactivates yesterday afternoon. And this was the lower of the two initial fissures from the very first day that is now putting up lava in this giant river that's pouring over the cliff into the crater and sending lava flows across the crater floor itself, as indicated there. And here's a USGS view of that lava falls that was created, a cascade of that river over the wall of a crater into the lower pit there. It's a pretty spectacular and dramatic imagery coming out from this phase, this fourth phase of eruption, which has also been the most voluminous. And the USGS has noted that with each successive phase, the volume and rate of lava coming out has increased. So here's a reverse angle of this latest phase with a fissure up and west of Nāpau Crater, pouring a river down into the crater floor. And all this dark material you see is a new lava flow as it was photographed early this morning. To show you this in a map sequence, here's a first phase at 2 paths on the left. And we'll go through to show you guys as it opens up to the right, that first flow coming down towards the crater, and a first pad of lava on the crater floor. Fissures continue opening across the Nāpau crater floor. The flow rate decreases, but still oozing out and putting flows across the crater floor until the reactivation of the original vents with the highest volume floods into the crater and creates the lava falls and paves the crater floor. Our latest thermal image looks as such. You can see that the hottest spots are at the actual vents and the open channel itself, but there are some pads of lava still emerging from the lower fissures on the Nāpau crater floor. And you may see some smoke and webcam images from some vegetation burning in this area. Briefly on monitoring signals, we can look at the tilt meters at Sand Hill and see that while the Halemaumau area is still deflating, it's doing so at a slower rate. The South Caldera, indicated by the green line here, is still deflating quite quickly, which means that the magma is leaving the summit area to feed the Middle East Rift eruption. And right now, that feeder system is not showing any indication of having slowed down or stopped, which means the eruption likely has some time in it still. How much, it's impossible to tell exactly. So that's up at the summit. If we go down in the Middle East Rift by the bend, by Mauna Ulu at the escape road, this is the site of the recent intrusions in July and August. We don't see quite as much change there. It seems fairly stable after the recent intrusions. And further, past the eruption site, down rift at Pu'o'o crater, we can see the azimuth towards the rift here is still decreasing. And so it seems like the pressure that was building underground that might have been deforming a larger area around Makapui and Nāpau craters now has been relieved. And so the swelling that you were seeing around Pu'o'o has been relieved a little bit as well. So that's the story on Kilauea's Middle East Rift, and we'll just have to wait and see what happens next there. On Mauna Loa, there have been very, very few earthquakes. It's been fairly quiet as the volcano reinflates. And the deep earthquakes perhaps are continuing, but still at very slow rates as well as we track that. So business as usual on Mauna Loa, and we'll keep track with Kilauea as she continues erupting. And that's our Hawaiian Volcano summary for this week. All right, so what we'll do now is we'll go into our volcanic hazard summary, because that is the biggest concern to people right now. And we are here for preparedness and awareness as well in response. So it's nice that the lava is only affecting the national park and not any people or infrastructure, although there are some cultural resources nearby. The Pulu factory near the eruption site is of concern as well. So to the gas, the main concern. And so it's coming out of two sites now is what's important to note. This image is showing a site at Halemaumau, and the USGS reports an emission rate of 60 tons of SO2 per day near the background, still emitting from there. Our new eruption site would have a triangle right in there or so. And so its wind direction would blow off like that as well. Right? But there's no indication there of that as well. So everything is in the green right now. But from the eruption site, the USGS is reporting upwards of 10,000 tons of sulfur dioxide on any given day, because what they're seeing is that as each phase begins, you're getting a new puff of gas of 10,000 tons per day coming out. So you might have 10,000, it might wane down to a few thousand perhaps, and a new fissure reactivates and you have another 10,000 coming out. And so that's been the way of it recently. So especially now at the beginning of the eruption, when we have more gas coming out, is when there is this greatest impact. And from this site blowing down to Kīlauea, we'll click on that site right there. Let's go to the history. It's currently in clear, but if you look at this history for the day at Kīlauea overlook, you'll see that it's been quite bad air down there for much of the day. And not just today, but even back to yesterday afternoon as well. So unhealthy, it's the orange to the red to the maroon over here, where it's actually quite hazardous. Right? So it's interesting because the national park has in fact reopened the Chain of Craters Road, and that followed that one-day slowdown that occurred in between phases 3 and 4. And so the road is open and people can go here coming across this gas. And because of that, the USGS has issued advisory that the hazards have increased along the road, even though it has reopened. This is the Kīlauea overlook itself that looks down over the coastal plain of Kilauea. They are saying that it's closed now due to the gases. They do not want you getting out of your car anywhere in this area and breathing this stuff. So likely there is signage down there, and follow the park directions because of that, right? They do also note that lava glow might be viewable from those areas along that road, which is why people were driving down there in the first place, if you're wondering. So that is the gas there. I thought we could as well turn to our usual VMAP, Vog Measurement and Prediction Project forecast from the University of Hawaii at Manoa. And that forecast has been updated to this higher rate of gas emissions. Right now it's at 3,700-ish tons per day. And from the emission site, I'm not sure if they've put this in exactly in the right spot here, but probably because I see it, there it is, coming from right there. And it seems to be blowing down. You see it swirling around Mauna Loa summit, filling a lot of Kau, and actually it will wrap around into the Kona area a little bit as well. Well, it's not quite as clear from this imagery right there. There it is, a little bit right there, coming in the Kona area there too. So when the volume of gas is this high, then you can be far away as Kona or even the Saddle or Hamakua and be detecting the gas and be impacted by it. So now is a time when everyone who is sensitive should take extra precautions to this gas. And to show what we mean here, let's pull up the purple air. This is a citizen science monitoring network. And this is measuring particulates in the air. So near the eruption site, the gas is coming out as more of a pure elemental sulfur dioxide. But as it flies further away and reacts with the atmosphere and the moisture and has the sun to help it react as well, then you have that particulate VOG start forming in that gas cloud. And that can be detected by these citizen science monitors a little further away. So you can see these values here in Ocean View and South Kona are all quite high. Even in Kailua Kona town itself is in the yellow, but some of these are looking really, really hazardous, depending exactly where and when. So be careful out there with the gas. This is the primary hazard for people. That's the takeaway here. And the reason we use the purple air is we can check in with the Department of Health state website as well. And let's see what it can show us here. Anything? Nothing?
Might need a refresh.
There we
There
go.
it
I got
is.
it to pop up. So yeah, we have 2 data points, one in Ocean View and one in Captain Cook, showing in the yellow there. So it is representing it a little bit, but it's not giving you the full picture that this gives you, which is why we're showing you this. All right, so we could use more state monitors, I suppose, is the bottom line there. So that's our volcanic hazard summary. And with that, we will this week go into our Volcano Watch. And we do that in this order today because this is written for the theme that I had prepared ahead of time for our presentation today. So this is going to be a nice little summary for us. We've already talked about this already. The 4 phases of the eruption so far are what they're outlining here. And they go through each of those as we noted before. First phase for 1 hour on the Sunday evening, and then Monday morning confirming the eruption had occurred, less than 4 acres. While it was not moving on the surface, they still detected it underground through seismometers, tilt meters, and GPS. Phase 2 begins on Monday evening at 6 p.m. They do detect additional signals in the thermal satellite, the GOES satellite, as well as the webcams, but that's basically it. Those decrease overnight, but between 4 and 5 a.m. on Tuesday, they see a combination of infrasound showing gas venting, the thermal satellite again, and webcams showing the reactivation or the opening of fissures across Nāpau Crater floor. And then just yesterday, the 4th phase at 3 p.m. with fissures west of Nāpau Crater, where the newly deployed S2 camera is recording the lava falls that have been going over that crater wall. So that is the Volcano Watch this week. They're recapping that same sequence, more or less, noting the history that there were many eruptions in this area during the 60s and 70s. Most of those between less than a day to about 2 weeks. In Nāpau itself, most recently, in 1997, there was a 2-day eruption, so we're past that already now. Kamoamoa in 2011 lasted 5 days. I think we'll get past that since we're seeing somewhat deflation. We're already on day 4, going into day 5 here. And they also note, of course, that there are longer-lived eruptions in that area, such as Mauna Ulu and Pu'o'o, and you might also note prehistoric Kananui Ohamo as a lava shield as well. But I will say that these 2 recent examples of Mauna Ulu and Pu'o'o that we have seen how they came about, they did not come up out of the blue from nothing happening to a 5-year or longer eruption. They had many shorter fissures that predated the main phase of activity for both of those eruptions. So we'll await and see what happens, whether this is actually the beginning of one of those phases, or whether we'll have a longer, more drawn-out reestablishment of the rift zone. And we can talk about that a little bit more in our monitoring section. So I'll move on and just sum up our Volcano Watch here, and we'll go to our visuals and our observations on Kilauea. So there's our timeline. Let's show you guys first how we started everything off in case you happen to miss our earlier update. This all comes back to the 14th when we had a magnitude 4.3 earthquake in the South Caldera, where magma pressure had been building following the 2 previous intrusions in the Middle East Rift in July and August. That both occurred in the area right around here, right around in here. And so then we had that earthquake occur, that tremor comes through, and our first eruption pops out just west of Nāpau Crater with a fissure line right there. And here's a USGS map blown up where they show their little pads of lava that came out, 4 acres during that first phase. Then we have that second, and now we're to the 3rd phase. The 2nd phase putting lava from the top down into the crater, and the 3rd phase opening the fissures on the crater floor and starting to fill the crater from the north end as well. That's the 17th. On the 18th, we had a slowdown, and so we only have a little bit of expansion of lava coming to the north and a little bit to the south. But then we do have the activation of the fissure that starts pouring down into the crater that comes next. And so I wonder, let me just jump ahead here to this slide and see if by chance they've posted a new map. Nope, looks like no. So we'll end that Kilauea maps there. Instead, what we're doing to find our maps is going to this preliminary eruption map website. Oh, just a moment.
Yeah, been very interesting, this progression, and I've been appreciating these USGS maps, these new ones that they've started to roll out and be able to update, and they're still a work in progress. But if you start diving into it, it's going in the right direction.
Yeah, so what's nice about these is they're updating these multiple times a day. And when they update them, the newest stuff is in red, and you see that pink color, salmon color for the slightly older iterations. So from that's where we got this map sequence that I'll replay here, showing the first two pads, the reactivation, opening of fissures on the crater floor, filling the northern segment here. The purple lines are the active fissures in any particular frame, while the white ones are the inactive fissures there. So here's a reactivation up top, the big flow in, and a flooding of the crater floor, once again, from those sequence of maps.
That is a cool little time lapse that you're able to get there, and it shows the little pop-ups of the other things that you're going to see in the time lapses when we start looking at those. You wake up in the morning and you find out, like, oh wow, this happened, and this happened too. All right.
Yeah. It's a little clunky, that little animation there, but hopefully we'll
it's pretty cool.
see a better one from the USGS, since they can actually size their field of view and layers a lot more easily than we can. Anyways, we also have the thermal images they've been releasing. So here's the first one, 2 lava pads just west of the Nāpau Crater, and what you're looking at here is where it's dark blue is where they scanned and it's cold, and where it's red is where they scanned and it's hot. So it's just the red areas in here are the actual lava pads, and the blue is the edges, so they're making sure they catch all around it and get the full image, just to be clear what's going on here. So that was that first phase. Second phase was a reactivation, so that's not caught here. The third phase are the active fissures on the crater floor, starting to fan from there. Here's that intermediate slowdown where there was only a tiny fountain and lava pond present on the 18th, up until the reactivation of the fissure up top, which then pours in, and you can see this much larger footprint of lava on the crater floor at this point in time. And similarly, the black here is where they've scanned and it's cold. The blue is where it's a little warmer than that, and the red's where it's the warmest. So you can see is that most of this lava flow on the crater floor has crusted over already, in fact. And it's still feeding. You can see that's still red on the edge. So lava is moving through the middle of this big pad and oozing out the edge when this was taken, but it has crusted over in the middle. So that's a thermal sequence that we have. And we can go in a little bit more detail. I thought we could, rather than just show you guys the imagery of each phase, recap the videos as well. So here is the first phase when we thought we had missed eruption that had lasted only an hour and put out a couple pads of lava there on the forest floor west of Nāpau, where most recently it had erupted in the 1960s. See here, this is the area where the lava river is going to flow down over the crater wall. So here's what it looks like before all of that happens. You see the lowest segment of fissure steaming, but no lava coming out yet on that very first day. Now looking back up the rift there, perspective, it's a nice before view for what's coming next. All right, I'm going to stop it there, and let's show the next one, which is actually just zooming into this particular eruption, but down low, so you can see many standing trees still. And if you look closely, there's lava tree casts around the bases of these still standing trees with leaves on them, showing how fast this flow came out here, right? That was a first burst of lava kind of clearing its throat in a way, flashed through here, and of course now the lava has come through and burned down a lot more than you see here in this video. But just a little closer examination of that initial spot. Right down here, this is a spot that's currently erupting that reactivated with vigor, and you see it there at the end of that first video. Okay, for that second phase, when we have the reactivation and then the beginning of, also the third phase, the beginning of fissures on the crater floor, here we have a video of that. And so we're coming, eruption sites coming up here on the left. This is Kīlauea right here with a summit crater. This is Maka Pui crater in the background. We're looking to the south. There's an ocean over there. Nāpau Crater is going to come into view at the left. So the first thing we see here is this pad of fume from that very first fissure that emerged on the 15th that has not reactivated at any point since. Actually, that might be this one right over here. Yeah, right in here. A little bit less fume. There was another segment of fissure that opened up further up. This is actually right here. This is a later video that's going to show that next segment there. So earlier pads of lava, and down here in the crater floor, you can start to see the fissures emerge as Nāpau Crater comes into view. It does appear, you can see how low the fume is blowing to the ground there, right? And you can see a little bit of this shaking of the camera. You can tell the helicopter is getting blown by the wind here as it's flying to assess the eruption site. Pause it here in the distance. There's Pool Crater. You can see it's got some steam or fume that's hanging in a crater still in this early part of the day. Interesting to note. And so 3 main fissure segments that are fountaining, but still you see fume and other activity coming up at the eastern end of the crater as well. Let me jump it ahead a little bit. A slightly different view there. Yeah, so you can see there's a little bit of forest down on this edge right here in this corner. It's one of the older flows in the area, and so as the lava comes over that, you might see some of the smoke popping up from this area over here. You can note in this earlier photograph, this is a 1997 fissure right across the middle of the crater floor right there, and there's a little pad in the bottom. It's a crater wall, and there's this big ridge in the middle. And what we're going to see is lava is going to sweep through across that western pad and down. So that's the third day, and actually they land this day and are able to go and collect a lava sample. This is similar to the video we saw put out from a recent summit eruption where they were able to sample as well. And it's the same idea. They're going and collecting the liquid lava. They are quenching it so it cools as quickly as possible because they're trying to preserve the chemistry of it as it was in the flow. And what they don't want is for it to sit there and cool slowly enough that crystals start growing and changing the distribution of the minerals within the rock. So that's what they're doing here. And you also don't want it to be contaminated with anything from the atmosphere either. So they're trying to be careful with that. So that's the lava sampling that they did. And let's see here. The third phase, when things are dying down, there's our small lava pad, as we noted. But this is right before the reactivation. So we have a reactivation happening on the 18th yesterday. And we do have this video that's posted online. It was posted on Hawaii Tracker as well. And this is from let's put it back to the beginning. This is a very short clip from a commercial flight. And you see a fissure, big flow of lava down here into the crater. There's a spot of fume coming off here to the left. It's interesting as well. So there's a little bit of video there for that reactivation. And let's keep going on the reactivation videos and come to the main USGS feature for today. So here we see that pad of lava, the older one. There's a newer one back down in here that came out recently with this reactivation. And here we see the river of lava that's pouring down. Nāpau Crater is back here. Lots of fume coming off of here. If you look closely, you can see how fast this channel is moving in here. It's probably hard to see, especially if I draw over it, but as you look in, you can see that. Most lava is going down in the crater rather than coming into the forest on either side there, because it seems to be a pretty good slope, fairly steady rapids, that all that river is moving as a giant slug of material, just sloshing over the edge right there. Looking at the crater itself, you see it's coming into the crater, and all the way to far end of Nāpau, this is the southern edge. There's a little spot of fume coming up. At this exact moment, no fume from these eastern fissures, but they may show something again here in the future. But As the helicopter comes around, let's see if we can come forward a little bit to check out this spot of fume. And it's just a little crack on a crater wall there. So likely the lava found its way into that little crack, and maybe some vegetation is in there burning away, or some moisture perhaps as well. So yeah, there's our view, reverse angle, looking at that flow into Nāpau Crater. And yeah, there is that lava rapids going in right there. And that is our USGS imagery. I think we'll do one more pass from the front seat here. Now you can see a little bit more easily the height of these lava fountains compared to the ohia trees in the background there. So they're saying it's about 30 feet high or so for the most part, these fountains. And perhaps also more easily see this big channel of lava that's flowing down. So one more video to show you guys, and this is from the USGS pilot at Volcopters on Instagram. And so here's a video that he posted. And I have it kind of zoomed in so you can see it as big as possible on the screen here. And there's that channel with a couple other dribbles coming down a little bit further west, but all in one big falls right here on the right. Notice the lava goes into some kind of lava tube right here. It goes underneath a crust, disappears from the surface before it reemerges further away. Look at that big channel. Overflow channels, braids in here. We're starting to build a spatter rampart along that southern side. And several little spatter cones where the fountains are occurring. All right, so that's it. If I zoom it out a little more, you can perhaps see his hand on a stick here as he's flying the bird around. So mahalo to Volcano Copters for that footage as well. Okay, so we do also have this nice webcam, the S2 camera that's looking into Nāpau Crater. And here is a recent view of it. Maybe I can reload it. Will it let me reload it? Okay, yeah, there it goes. So there we go. There's our view of our lava fall right now. You see that the big channel is the one that's still open, and perhaps those smaller dribbles have closed off and are no longer visible right now. You also can't see very much glow in this part of the crater floor at present, perhaps because the lava is going underneath that crust as it moves across the floor there. So that's the current view. We do have this automatic 24-hour time lapse that USGS has put out, but we can give you guys a better resolution, give you guys more frames in that. So let's show you guys what there is. This is the original S2 camera animated from the very beginning of its deployment. So let me pull it back here and start. This actually starts off at the beginning of phase 2. So you see that first fissure on the floor of Nāpau. They move over to the right. You start seeing fume coming up from the right here. They die off, slow down overnight, although lava is still moving. There's a little bit more coming out from that small pond and vent right there. You see fume coming up. And now we see that new burst coming out. The lava falls, emerges, starts putting flows across the floor of the crater, glowing through the night. It's still moist out there. It's raining, so you get some bad frames in there, but it shows you what's glowing and what's not. And yeah, continuing, there it is. And one of our more recent frames earlier this afternoon, you can see some smoke over here on this right side too, is perhaps either those fissures reactivate, or this big flow that's filling the entire crater could, in theory, come wrap around at some point, and we won't know until we see more data from the USGS, of course. So that's the zoomed out view, and let's get it a little closer for you guys and show you there. There's that fountain at the base of the Nāpau Trail into the crater there. And here we are on the evening of the 17th, when things slow down. Still some action on the crater floor. Still some glow up top a little bit. Quiet, and here comes the reactivation about now. There goes all the falls. Yeah, so here's what I'm going to do. I'm going to pull it back. Even at the very beginning, there are some things you can see when lava first comes across. Let's see if I find the frames that I'm looking for here. Yeah, what's been interesting to me is this pattern of lava coming over the crater wall and lava falls. I'm sure I'm not the only one interested in this, right? So there's that very first dribble down. You see that at first there's a bigger volume on that left side of the image and a smaller one on the right, but that's going to switch off, right? It kind of spills over like a surge. It splashes over on this side first before it continues longer term down that chute. Well, there it is. And as we go through, well, there's some extra dribbles here on the left side as well. Gets very, very bright. And what you can see is in the middle of this, these dribbles here on the left side seem to get crusted over and die off. In fact, in both of the arms here seem to wane and crust over for a little while. And so this is just part of the pulses. By morning time, we see the glow there up top. We see dawn with exposed lava falls once again. The dribble comes back in here on the left side. Look at that. It comes in this morning once again. Expands a little bit. It's putting on a lot of gas there. Shuts off by right around in there. So it's interesting to note there's some other little trickles coming down on the west side as well there.
Yeah, it's really pretty cool just to see the it die off and then it'll restart just like an hour later and make a new flow that come down, and then it switches to day and the old channels has the lava in it. I don't know, just the sequence of that camera in the morning was interesting.
Yeah, it's pretty interesting area out there. Yeah, and unfortunately there were some really nice lava trees around there. They're likely all buried, but that's what these volcanoes do, is they keep reshaping themselves over and over. If only we're so easy to do that as people, right? A couple last things here in our visuals. Let's go to the PW camera to wrap things up here. So this is an animation. I'm got a much faster here, but here's the eruption site at Nāpau, or west of Nāpau Crater is this whole area right here. So in this particular frame, there's lava in the crater going around that southern side and getting some of that vegetation as well. So I'll play it from the beginning here. I thought I was going to play it from the beginning. Let me get it ready again here. There we go. So a little bit of glow. When a few first clears, you see a little bit of glow. Then you see the eruption site. At night, you can see it's been pretty socked in. You get occasional glimpses of that glow. You see the fall is going to come, and they will fill into the crater. That was a pretty fast view because I'll show it to you guys again, but zoomed in a little more closely there. So if you're at Pu'o, this is the kind of views you would be treated to from that distance away when the weather cleared. Right? Of course, our eyes are better than these cameras, but still we can see a good amount of what's happening there. Yeah, from Pu'o looking west into Nāpau Crater. All right, so that is our visual observations that we can report today. There's a lot to talk about as far as the earthquakes, the monitoring, and other topics as well. But I will pause here and I'll pass it off to Dan and Lou to talk about our community happenings and our sponsors. And I will also go deal with my power issue.
Yeah. So we'll see Phil when he gets back. Thank you, Phil. And I'll bring in Lou. Hey, Lou.
Hello. How's it going?
How you doing?
I'm good. I'm good.
Busy. Let's see. We're also playing between the power issues. We're also trying to figure out whose internet is going out as well.
Right.
So
it could be any of us at this moment.
We're working through some technical difficulties right now, but it seems to be going. So I want to just start off by thanking everybody for being here. We rely on viewers like you. The likes, the subscriptions, the shares, all that stuff really does help with the algorithm and the back end on YouTube to get more people out there. If you're new here, if this is your first time stopping in, consider subscribing. It's free on YouTube. And yeah, we do this every week, Thursday at 5 p.m. Hawaii Standard Time. We go over the latest on Kilauea and Mauna Loa and provide a little bit of insight on what's going on. And Philip
We've been doing this since 2018. Philip's a geologist by training, goes back a long ways, this whole thing. But yeah, we'd like to also thank our supporters. Lou?
Yes, that's what Dane was saying there. We are a Hawaiian Volcano Education and Resilience Institute, a 501c3 nonprofit organization. Your donations are tax deductible, and it fuels everything that we do that you see here, as well as all the behind the scenes with the volcano education, our digital resilience programs, as well as the building of our youth development program. Thank you to all of our sponsors that take care of us and all of you individual supporters. Dane, we did have a super chat come in there. You want to throw that up there?
I did want to throw some super chats up. We had a $10 donation from Buster Brown.
There we go.
Mahalo to Philip, Dane, and Lou, and everyone that helps put this together. Appreciate the support there. BB. And then we had a $99.99 super chat from Kelly Dude. It says, thanks for your work and your time. Really appreciate that support there. That's huge.
Right on.
Thank you so much for that. And
that's great.
Yeah, we also do take donations through our website, which is hveri.org/donate. And yeah, we take them anywhere, but on there,
that is the best way to donate to us, is at hveri.org/donate.
But we appreciate it anywhere. Like, don't. Yep. We take what we can get here, and we appreciate it all.
Well, let's jump into the community corner. What do you say?
Yeah, let's do it.
Let's see what's going on here. Well, as you guys all know, we do have park closures. We know that. The best thing I can tell you for the park right now is, if you're going to the park, check the website. Closures happen at any time. Openings happen at any time. Check their website and stop at the visitor center. Be prepared. There's going to be more people than ever up there, especially since everybody thinks there might be a chance to even just catch a glow. So check out what's going on up there. You can see here, I can't quite see that. Let me switch screens real quick. The Manaulu, Nāpau, and Nalu trails are closed. That includes the Manaulu Trail and parking area. So they don't even want you stopping on the side of the road. There's fog everywhere. So don't get stuck out there. Just check in with the visitor center. It's my best recommendation. The park did put out a notice. I'm going to read through some of that real quick here if I can. Sorry about that. I got to switch sides here. There we go. So,
you want me to go ahead and read?
I got it. I just had to. I'm out of my normal work zone here. Hawaiian Volcanoes National Park puts out a notice. This was only, 2 hours ago, Dane?
Yeah.
Eruption hazards increase along Chain of Craters Road. Chain of Craters Road is open to the sea arch, but volcanic hazards have increased from the eruption near Nāpau Crater. The Middle East Rift Zone eruption significantly increased in volume on the afternoon of September 18th. Hazardous concentrations of volcanic gases and particulate matter may occur along Chain of Craters Road due to the ongoing eruption. For your safety, do not stop at the Kīlauea overlook or surrounding area, and follow all posted signs and rangers instructions. And that's important, because it's not just the dangers of the lava and that it's the bog. That's why you hear Phil talking about it all the time, throwing up the bog map. Manaulu Trail and parking area, Nāpau Trail and Naulu Trail remain closed to all use due to continued eruption hazards, including gas emissions and for potential wildland fire. So you can see, let's go to the next page. We did post all this, so if you want to go through it, we do have that up on our website as our Hawaii tracker. Let's see, lava glow may be viewable from open parking and pullouts along Chain of Craters Road. Check the park website for best viewing options and times. Visitors should be prepared for heavy traffic, long lines and cars, limited parking, and no restrooms. They're not going to have a porta potty out there. And once you get out on the road, it's lonely with no porta potties. No eruption viewing possible. All right, so that's what's going on there at the eruption. Phil's going to cover more of that. I just wanted to give a big mahalo nui to everybody at the Hawaii Native Convention. It was an an amazing experience. I'm still over here. I'll be back tomorrow. And the Puna community that was over here supporting us, there was so much aloha and pono spread to everybody. Everybody knows Hawaii Tracker and HVERI and all the work that we do. And it was great to listen to all of them come up to us and say thank you. And I just want to say thank you to all of them for the great open arms. It was a wonderful time. Just a couple shots from there. That was from last night. And we do have an event coming up on the 28th, the Civil Defense Disaster Preparedness Fair in Waimea. If you're up there, come check us out. We'll have a booth set up. Yep. So come say hi.
All right.
And that's what we got. That's our community corner.
All right. Well, thank you, Lou. I did want to just again thank Adam to hear the Puna Strong and through the County of Hawaii and Hawaii Community Foundation, their support to be able to make all this possible, and
Absolutely.
As well as support for our other programs as well, which includes digital resilience and now youth development.
Yeah, and we couldn't have come in and experienced this convention over here without the support of the Hawaii Community Foundation. So thank you very much to all them there.
Yep. All right.
All right.
Well, thank you. And
You're welcome.
Let's see if Phil's back in order and set up and ready to go.
See him there. I think he's ready.
All right. There we go. All right. Welcome back, Phil.
Hey. All right, that's awesome to hear about, and yeah, it was great to see the crew out over at Waikoloa for the convention.
Yeah.
All right, so let's go get into the rest of our data here. We will go into the recent earthquakes first, actually. So let's go and check out what the earthquakes are doing. So to start off, we're looking at earthquakes from the last 2 days here, island-wide, and these are colored by depth. So what you're seeing is not as many earthquakes as you might usually get. There's a settling earthquake deep under Mauna Kea. We have the Pahala deep hot spot earthquakes ongoing as well. And otherwise, we have what's happening in Kilauea over here, which we'll look at here in more detail. And then we have 3 earthquakes in Mauna Loa. One that occurred just today, the 2.1, about a mile down. And so it may be that there is some small adjustments of Mauna Loa in response to Kilauea, but if so, it's nothing major. It's just a little bit of adjustment here and a little bit of adjustment there, kind of thing. So coming into Kilauea a little more closely is what we're interested in. And what you might notice is that in the last 2 days, there have not been that many earthquakes. There have been some around the summit, a handful over there. And the cluster of anywhere is right around the eruption site, just a little bit west, in fact, right in there. So it could be that there's some adjustments happening in that area underground. But really, when you think about it, and if I were to put up on here, let's see, the recent lava flows and put up our actual eruption right now, including the fissure lines, what you might see is that for this whole area, all of the fissures have emerged within this 1 mile window right in here. Right? So overall, this might suggest that the pathway from deep down is actually fairly well established. And it's not popping up like over here and over here and over here. It's actually found a spot in here. And as far as where it's coming to the surface, the actual nozzle is changing, but the feeder pipe does not seem to have moved. It seems to all be in the same area, right? Which may be why we're seeing deformation focused around here and not progressing further down the rift, in fact. So the earthquakes are down a little bit there. We'll look at them plotted any other way. Let's see if we can get that to load here. So now we're colored by time. And we have the newest one first. So the newest earthquake was a Deep Pahala event. The one prior to that was on Mauna Loa. The one prior to that was down on the south flank here of Kilauea. And in fact, all the ones recently, just in the last 1 day, have been the south flank. As you imagine, as magma is feeding into this area, well, into this area right here, here's where it's feeding, that you might have push against the south flank and cause south flank earthquakes in the zone over here. So if we look at let's zoom it back out again, what the largest earthquakes actually are this past week, and we have a couple 2.4s the one at the summit, and a deep one off Pahala as well, but nothing as major as we had the previous weeks. So that's really it for the earthquakes. And that's typical that when you have an eruption begin, that earthquake rates actually go down. So in fact, I can show this as well here. The earthquake rates and depths for the past month, earthquakes per day. And our current day is this little bar way down here. It's almost not showing up on the graph. So you see that we already went down quite a bit since the onset of eruption here on the 16th, night of the 16th was really more or less where this line is, I guess, was when eruption began. So earthquakes went down quite a lot and are still dropping down at present. And if that pathway to the surface were to need to be reestablished, then you might see earthquakes pick back up again. And then that might tell you that maybe the supply route is not so stable as we're seeing right now. But all good for now, and that's the earthquakes that we have to share. Along those lines, not exactly earthquakes, but coming into the monitoring range here, we'll show you guys the seismographs from stations on that Middle East Rift. This one's kind of Yohamo. I have got one from Pool as well. So this goes back to the 14th. Here is at magnitude 4.3 earthquake. And then here is that intense series of micro bursts of earthquakes and or tremor, hard to tell what's overlaid on the other, that occurred immediately following it. And we have lots more earthquakes still ongoing. All these little heavier spots of ink are all earthquakes. And that goes on for over a day until right around in here. What you're looking for is this little background line gets a little bit thicker in this band right in there. And that is the lava leaking out of the ground without a whole lot of fanfare. In fact, the signal that the USGS picked up was from infrasound. So they're actually hearing the gas roaring through the atmosphere is how they picked that up, rather than this tremor signal. But this is here also, it's just more subtle. So there's the actual very first phase eruption right there, and it dies off. So let's go to the next day. And here's the next day. It's still fairly slow. Lots of earthquakes still happening, but you can note right around 4 to 5 a.m. at the reactivation, that second phase is when the tremor gets thick and heavy again, right through there. And over the course of time, it gets a little bit lighter and lighter and lighter, decreases more gradually, right? These are 48-hour plots, so I'll come into the most recent one, maybe. Come on. There we go. Most recent one, where yesterday at around 3:15, right there, is when we have the beginning of the fourth phase right here. So this is the opening of the fissure on a crater wall, and then lava's now flowing down into the crater. And what you're seeing is it's been pretty active since then, but within that activity, you certainly have stronger and stronger pulses coming through, right? So very clearly, like this may be the first pulse, you could count it over here, a second pulse, a third pulse, a fourth pulse coming through as well. But these are pulses that are increasing in intensity rather than decreasing in intensity, which is a little bit unusual here. Not what we've seen in the past. So that is it. And where we currently are right now is down here at the bottom. So you can see we've actually come to a little bit of a decrease in the effusion rate recently. But this KNHD seismograph, which you can get from the USGS website, is a good one near the eruption site to look at these pulses of when there might be a little bit more activity. Like if you're looking at the webcam and you see it suddenly get really, really bright, I might run over here and see, is this actually an increase in intensity of the eruption rather than something unblock the camera view or something like that, a cloud of some kind. So interesting to note, though, that this might be the most useful monitoring signal at present is this tremor signal right now. But we also have the tilt to rely on, and so let me come here to the top of this tilt page. At Uekahuna at the summit, we are still deflating. The rate isn't massive, but it is there. Right? You can look over the last 2 days. We're at 2. We're down here at -3, so 5 microradians in 2 days. Nothing major, but it's certainly a deflationary pattern there. So, and this is the signal that we expect from a shallow chamber of Hale Ma'uma'u. And to recap that part of it, let me throw up the cross section, which we maybe haven't done in a little while. But under Kilauea, it's believed that we have a shallow magma reservoir called the Hale Reservoir with the H here. And we have a deeper one. That's the South Caldera Reservoir, marked SC over here. And what you can't tell from this image up and down is that in map view, the Hale shallow reservoir sits further north within the main caldera, and the South Caldera Reservoir is on the south edge of the caldera, as it's so named, right? So the reason I point that out is when we go to the tilt here, and we're looking at this signal, this is the one that's telling us about the shallow reservoir. So it seemed like it was very quickly deflating, slowed down for several hours, and now has resumed deflating, but at a slower rate. Right? So that's the shallow chamber. The deeper chamber is the one that we get at when we come down to this Sand Hill Station and this green line. That's the area that's the South Caldera Reservoir. So on this signal, you can see that the tilt is decreasing more slowly at the shallow, but it's still decreasing quite quickly with a little bit of a slowdown, but not that much slowdown from the initial rate of deflation there. So the USGS will state that the South Caldera deeper chamber is still feeding the eruption, and this is the data where interpretation is coming from, right in here. This is the most obvious signal. You don't see that quite as clearly anywhere else, but there are other signals as well. We mentioned the escape road area near the two previous intrusions is fairly stable. The focus of activity is migrated east to Nāpau now. So like now that's just like a stop on a subway line. It's not the actual destination. So it's just going right through there and passing through without changing a whole lot and erupting out of Nāpau. And Pu'o, further past the eruption site, we saw it react to the intrusion. We saw the reinflation from the west at a very fast rate early on, and that seems to have slowed down, as you can imagine, that even as magma is coming into the area, a lot of it's getting out through the eruption right there. All right, this is that western signal, the green one. And the blue signal that we know that there was some rainfall and perhaps some other intrusionary signal in the area does seem to have resumed its regular pattern, right? It does look almost like rain because it's resumed the exact same baseline that it had before right there. So that's interesting to note as well. So still nothing right under Pu'o. It's all west of there at Nāpau. And looks like this didn't quite load either. Let's see if we can get Jonica on a screen here. There's Jonica further down the rift, showing a couple of jolts from the earthquakes. But overall, the tilt starts really close to zero and ends really close to zero as well. There's very little change there. So Lower East Rift, nothing to worry about as far as deformation at present. So that is our tilt signals. That's most of what we have. And so once again, a cross section. Shallow caldera and deep caldera are probably both feeding into the rift zone, coming up by Nāpau, right through there. This one, smaller, has relieved its excess pressure more so, and this one is the one driving the push at present, right? So that's actually telling you that it's not all still just pumping out of control, like, it's not like a runaway train here. We actually are seeing a reduction in pressure have effects on a shallow chamber first, and eventually you will see it do so for the South Caldera. And now we might come to some of these interpretations of what might actually happen next, right? Could there be like a long-lasting eruption like we had still in 2018? The one big difference is what's happening above this chamber up here since 2018, because we had a major collapse. We've refilled a lot of that with lava through here. But still, we only have about one quarter to one third of the lava reoccupying the crater that we had in 2018. And that was what actually created this plug above the magma chamber to allow enough pressure to build to the east rift to sustain a long-term eruption. So we'll see what actually happens. I've heard some talk about what would happen if the eruption becomes long-term right here. So of course it's fun to guess and speculate what might happen if the eruption stays right here. What if it went to the ocean? Where might it actually go? But there's no indication yet that it actually will last that long. or if it does, it will build enough pressure to reach that far. And so it's still a developing story, and I don't know that that won't happen, but it's not quite so foregone as some people are saying here. All right, so to finish off our monitoring segment, I have to reload this page as well. Let's see what's going on here. And I'll have to show you guys. This is the USGS Volcano Notice Search. And here's how I use it. You have to click in a certain order. Click the days first, click the observatory second, you click the search third, and then you get what you're looking for, what I'm looking for. The most recent USGS update today. So I will not read everything here. I'm just going to highlight a couple of phrases. They are noting that the fourth phase and fourth vent system with lava falls that occurred. We've gone through all of this already. So let me pick out what is interesting here. Very few earthquakes at the summit. They have a new report of SO2 emission rate from September 17th at the summit, 60 tons per day at the summit, to go along with what's happening down at the rift, which is often more than 10,000. They're noting the flooding of Nāpau Crater floor. Here's some good information. The rate of coverage shows lava's erupting roughly at 5 to 15 cubic meters per second. 5 to 15 per second. So for reference, the long-term supply rate is about 4, we believe, somewhere in there, maybe 3 to 5, somewhere like that. So 15 is on a higher end if that's what's happening, and 5 to 4 would be what pool could sustain for a while. And so it's not nearly as much as what we saw in 2018 or in 2022 with Mauna Loa, but it is on the high end of the Kilauea activity, as is typical here. So by this morning, they're noting 2/3 of the crater floor was covered in lava since Sunday, and that's 500,000 square meters or 125 acres of land there. They note that there are no changes in the tilt meters on the GPS either, so everything is still focused on lava coming out of the ground. One thing to note here, each eruption has increased in volume. What they mean is each phase of the eruption has increased in volume, with the current phase being the largest to date. Yeah, that's corrected in the Volcano Watch, I believe. Multi-day fissure eruptions are not unusual, and current eruptive activity appears to be linked to supply of magma from the summit. So they're referring to that deflation signal still happening at the summit there. Yeah, so that is really it for here. Let me continue on to highlight some of the previous information. They document the phases changing as well. So I will continue past that one to the update from yesterday morning. They are noting that residents of nearby subdivisions may experience gas emissions, which may increase and decrease over the coming hours and days. So that's still the biggest hazard here. And here is where we see that note from the magma reservoirs, about which magma reservoirs feeding eruption. So they note the Sandhill tilt meter continues to record deflation, while Uikahuna at the time had shown less deflation. And here is the key. This pattern suggests that only the deeper southern summit magma body is now supplying magma to the Middle East rift zone. And so that's the key there, right? That one area, why I showed you guys the cross-section there. And maybe it's both now a little bit again, but it's really showing the evolution of the pressure system within the volcano. All right, more phase changes reported here, more earthquakes are reported here. Did I miss? I think I missed the SO2 rate up here on today's update. So let me scroll back up and catch that. I noted the 60 tons per day at the summit, but where is it here? Sulfur dioxide rates on September 18th yesterday were 10,000 tons per day for the new vent that opened in the afternoon. So with our new phase, we got another 10,000 tons per day yesterday. So now I'll jump back down to the other update and note the previous gas emissions here. September 17th, they were 12,000 tons per day in the morning and dropped to 3,700 tons per day in the afternoon. So why? It may reflect a decrease in the rate of effusion, or be because the two eastern fissure segments got less active. So those are the emission rates reported there. If we go even further back, let me just jump while I'm on a gas emissions, come back to the previous day and look at its emission report. Where is it? Somewhere in here. Here it is. Measurement of the rate along the road downwind on September 16th indicated the inactive fissure system was emitting around 300 tons per day. So there's another point of reference. When it's inactive, it might be 300 tons per day. And that's your range. Yeah, so you got to add all those up. You add the 60, you add the 300 from here, you add the 10,000 from there, you add the 3,000 from there, and all together, you might get your full emissions from the volcano. So a lot of gas flying around, and that's why it's the main concern right now. And yeah, that's most of what there is to highlight here on these updates. And so I will leave it at that here. And we'll move on to finish up with talking about Mauna Loa first, just in slightly more detail. Right, here is a summit tilt on Mauna Loa. Well, this is not. Thank you. All right.
It's been one thing after another today. Like it really has.
Why clicking the mouse doesn't work suddenly out of the blue. All right. So here's our summit tilt for the last week of Mauna Loa. Starts just below zero, ends maybe just above. So it's a very slight inflation pattern still ongoing as it recharges following the 2022 eruption. Here are earthquakes over the last week, still mostly shallow. We had one slightly deeper one deeper one come in here in the last day, which adds to the ones we saw last week, which we only had two. And there's that long-term pattern of tilt, a little more easily visible over the month as an increase. And here, the couple of deeper earthquakes we had last week and the one we had this week. And why we're curious is because we've seen these deeper earthquakes suggest injections of magma from below into the volcano. So it doesn't look quite like that yet. It looks like it's just moving a little bit and settling in some ways, but it could be because pressure is coming. And so we'll wait and see what happens next on Mauna Loa. Still, earthquakes are very, very low. This is all just background of background interest because there's no threat from the volcano right now or any time in the near future. So that is Mauna Loa for us. And that is our lineup. So we can get to some questions and discussion here. And not that we know what will happen, but we can certainly talk about it.
Yeah. So it ended up you went through and answered a bunch of questions in the chat, especially some of the bigger ones that were more prevalent along the lines of, will this become its new long-term home? And will this become a new pool? So I think you've already addressed some of that. So you have just a couple outlying questions. Yvonne has one, just looking back at the past few weeks. So I guess all the hot ground near Makapui I saw in the past 3 weeks was probably a precursor. I'm not surprised when the eruption started, where it started.
Yeah, I think that's right, Yvonne. I think that probably was a precursor, right? I mean, we probably saw magma was ascending from that deep area already. And it just took a while to continue pressurizing and cracking to get far enough up where not just the gas could come out, but the lava could come out also. So yeah, absolutely. It was really cool to to follow Yvonne's experience as she's reported going out there and tracking the crack spring, not just on the east rift, but southwest rift as well, and all these changes on the volcano. So we appreciate your reports, Yvonne.
Buster Brown was also talking about noticing increased gas in that area too, but it's always so hard to tell with the visual on gas because it's so weather dependent. But yeah, definitely interesting.
Yeah. In any spot along the whole rift zone is a candidate for gas coming out, right? Because all those areas have old magma reservoir storage areas, and some of those are shallower than others. And it's really the magma getting shallow enough that allows the gas to exsolve, to come out of solution and bubble out and be released. So there's a lot of different things happening in there.
And then we do have a question. We have a question from our ASL interpreter, Dano, up top, who asks, how tall is that crater wall?
Of Nāpau, that's a good question. I saw that written somewhere, but I forget now.
Somebody looked and was saying 140. Does that sound
That sounds about right.
That sounds about right. They were looking at a topo
map.
Yeah.
So what you have to realize is on the west side, it's a lot taller than on the east side.
Right.
On the west side, it probably is about that deep, that tall. But on the east side, the trail actually kind of wiggles up the wall where it used to. So you actually could climb out of it, so to speak, right? It might have only been 10 or 20 feet at that end. So I haven't looked at the topo, right? But it appears if you look at how the lava is filling the crater now, let me see if I can pull that picture back up here. This one here. Nope, that's not it. This one right here. If you see how the lava is filling the crater, it's filling it all on this deep end, right? Here's the deep side of it, and here's the shallow side of it. So it might be that the bottom is actually tilted over that way, and that's why the lava is filling in this side. That's one possibility. I'm not sure exactly, right? It's also coming out at that end, so it would also make sense for it to stay there for that reason too. But yeah, it's quite a bit taller on this side, and not so tall. You know, to get in the old pool or trail, you know, come through here, go across there, and go down this lava flow, kind of cut across like through there, more or less something like that, and comes out like this and keeps going off that way. So a lot of this is covered in here right now.
All right.
And yeah, deeper side maybe.
Thank you for the question, Dano, person above me, and thank you for the answer, person below me, Phil. Daniel Dawson has a question here: is why is the floor of Nāpau Crater so barren? I mean, prior to it being flooded with lava from this eruption, of course. So, and we know it's been flooded with lava before, but yeah.
Yeah, it's that. Well, that's the answer. It's been flooded with lava before, and not that long ago, compared to how fast the trees are growing is what it comes down to. And so there are a couple other things that are important there. How fast do the trees grow? Well, maybe not that fast. You know, it depends on the amount of rainfall, and so you get enough rainfall. But it's the lava covering them, and then the lava retaining heat for some time to prevent things from germinating as well. So we have gone through this in our previous updates.
Right.
Last month, the full sequence. We actually have an image. So we have an image from 1961 of trees in this crater when it's all the way forested and lava's flowing into it and burying them at that point in time. So that's when there were trees that got destroyed, was back then. And every successive flow since then has set back the progression of recovery. And that's the real answer, Daniel.
And you have that stripe that you can see running across the center of Nāpau Crater. Isn't that like, what, 1997?
1997, yeah.
So lots of activity in that crater.
Right, yeah. That one was I want to say about 24 hours. Might have been 2 days, but over 24 hours. But it only covered
that little swamp.
That much.
Right.
So you wouldn't, and you do see like maybe some of the older flows around in here, you do see more vegetation on them as well. And so when you see smoke coming up from the crater, that's likely where the lava is reaching in some of these forested areas, like down in here especially. Yeah, it's interesting, right? Look at the walls. You can see there's actually vegetations on the wall, on the scree slope here, at a Taylor slope, but not on the very bottom.
And I'm not sure on this one. I was just gonna see if you knew something. But Patricia asks, I've signed up for alerts on USGS Web, but they send emails late. Is there a place we can sign up for phone text alerts? And as far as phone text alerts, I think it's just the earthquakes that they do. Maybe you know more than I do on that.
I don't know the answer to that. No.
Yeah. I tried to look it up, and I saw that they do phone alerts for earthquakes, but you probably were looking for like VANs and stuff like that being delivered on your phone. And I think those are mostly just, go ahead.
Yeah, the people to ask would be HVO themselves. Ask
Right.
HVO at usgs.gov. So
Yep.
just sure that's where I would write an email to them, and even if they don't have it, they will then know that people would like that, and maybe they will make it happen, even if they don't have it already. So they're who to ask.
Well, that will be it for the questions and answers section. Thanks, everybody. A lot of action this week, and yeah, a lot of action. We'll see what it goes from here. It's surprised me with this reactivation. Kind of, I thought it was going to be, phase 2, phase 3, and similar like that. Then yesterday, lava falls coming off of the cliff and a fountain. It's like, oh, surprise, we're doing this.
Yeah, it's actually not too dissimilar from the 60s patterns where we're seeing, some of those.
Yeah.
They start for a day, they stop for 24 hours or longer. Then they start again. Sometimes they start again like a mile or two away, and that's what we have not seen here. They've started up again all in the same spot, and that's what's interesting to me. Right?
Yeah, and it was beautiful to do all those 1960 episodes that we did, and then the eruptions in that area happening just after we finished the series, essentially. So the timing was very convenient.
Yeah, Kilauea was watching, and she's like, okay, this is the week you're free, right?
Yeah, right.
Except we weren't.
Yeah, we weren't really that free. All right. Well, thanks everybody for your questions, and thank you for tuning in. We are live every Friday at almost every Thursday at 5 p.m. Hawaii Standard Time with our volcano update on Kilauea, Mauna Loa, and the happenings here on the island. So if you're interested and you've stuck around this long, consider subscribing. It's free on YouTube. And we also manage the Hawaii Tracker Facebook group, where a bunch of people are posting images, and maybe not as much as the last eruptions, because it's kind of hard to see this one, but we're still getting some posts up and information being shared there. So check us out on Facebook if you have it, on the Facebook group Hawaii Tracker. I think that'll do it.
And
for
if
me.
you go flying, go to Hawaii Tracker and post your images or videos and share them with us, and we'll share them out again as well.
If you get lucky enough to get in a thing and get authorization to get up there, please do.
Yeah, there may not be very many people that do that, but those who do, hopefully will share.
We were trying today to get up there, and nope, told no. So hopefully that changes, and we can get up, or something can happen.
Yeah, so we'll see what there is to come next with this eruption. It could peter out from this one phase, and that could be the end of that, or there could be further phases ahead as well. Depending on the nature of those, we may cut back in before a week from now. But if it's something that you're able to follow through the regular text updates and images and videos that we're posting, then we might hold off until next week, Thursday. We'll wait and play it by ear on that. Go with the flow.
Yeah.
So, yeah, perhaps until next week, if not sooner. From the nonprofit Hawaiian Volcano Education and Resilience Institute, or HVERI, I am Philip Ong. Above me is Mr. Dan DuPont. Mahalo to our ASL interpreters, Daniel and Carrie Kaufman, as always, and our producer, Lou, on the back end as well. Well, mahalo, everyone, for your support. And until next week, aloha.